Welcome to everyone from on Zoom and LinkedIn for joining today, and to our panel, who I'll introduce shortly. We're talking today about next-gen intelligence at the edge. And as edge intelligence increasingly defines how we interact with the world, from smart homes and cars to factories and hospitals, the convergence of sensors, microcontrollers, and AI is rapidly shifting the innovation landscape. Today, we'll unpack where that convergence is headed and how global leaders are making it scalable and real. And we have some global leaders in the field on the call today, and we have some Frost and Sullivan colleagues who I may refer to as Frosties. If you wonder what that means, that's colleagues of Frost and Sullivan. So let me introduce today's panel. We have Jabez Mendelsohn, Research Manager at Frost & Sullivan. Jabez leads research on edge intelligence, embedded AI, and transformative growth trends across microelectronics, sensor electronics, and semiconductors. Secondly, we have Varun Babu, Industry Principal at Frost & Sullivan. Varun brings a market-wide perspective on technology convergence and opportunity mapping, with deep expertise across manufacturing and sensor ecosystems. And from our industry participant group today, delighted to introduce Kurt Busch, CEO of Sentient, a global pioneer in ultra-low power AI chips, purpose-built for edge devices, enabling intelligent audio, vision, and sensor-based applications. And last, but certainly not least, Harry Kroeger, board member and president of automotive business at SEMA.ai. SEMA.ai is spearheading innovation and go-to-market strategy for embedded machine learning in next-generation automotive and autonomous edge applications. So that's your panel, a pretty good panel in my estimation, and lots of interesting dialogue and exchanges to come. If we could just look at the agenda today, so we'll try and run a tight ship in terms of what we're going to get through. So we've got four main elements here. And to start with, we'll have an overview of the key drivers, challenges, and strategic shifts powering edge AI today. Then point two, we'll explore how industry leaders are shaping the edge across hardware, integration, and system architecture. Then thirdly, we'll dive into real-world applications across sectors like automotive, healthcare, retail, and manufacturing. And finally, we'll close with a forward-looking perspective on where the edge is heading, from silicon to systems to ecosystems. So the process will be, I'll mix it up so it remains sort of lively, and we'll have some introductions and some content from our Frost team, and then we'll hear from our sort of industry participants, Kurt and Harry, on how they're dealing with these opportunities and facing these challenges within their businesses. So a good content, a good combination of sort of Frost content and sort of real industry sort of experience. So let's move on, if we may, onto the first section on the evolving landscape. So I'd like to introduce Varun, so he can walk through the key trends that are transforming basic IoT into intelligent edge ecosystems. Varun, over to you, sir.
Thanks, Gary, and welcome to all the panelists who are here. And so if you take the edge AI intelligence, like simple IoT device have transformed into a intelligence edge nodes that can process, analyze, and respond to data right where it is generated. And this advancement is driven by the advanced sensors, powerful microcontrollers, and energy-efficient AI chips. So as a result, if you can see, companies can reduce latency, cut down on cloud dependency, and enable a faster and automation directly at the edge itself. And now the questions is like, why edge AI matters now? Like if you can see the localized intelligence, edge AI process data directly on devices like sensors or cameras. which reduces the latency, boosting privacy, and also improves the reliability and also eases the cloud dependence. And for example, you can see smart cameras analyze video on device, and some smart speakers also process the voice locally. And secondly, you can see the edge AI is transforming the vertical industries. For example, you can see in manufacturing sectors, it's powering predictive maintenance applications. For example, you can see Siemens MindSphere Edge. Now it is rebranded as Insights Hub. It uses a vibration sensors to detect equipment faults before they cause a downtime. And in the case of healthcare sector, you can see handheld diagnostic devices run AI models on site to spot anomalies in X-rays or ECGs, bringing advanced diagnostic closer to the patients. And thirdly, you can see the hardware and software advancements which are driving the adoption. We now have a powerful yet energy efficient edge hardware like AI accelerators, microcontrollers, and industry gateways. On the software side, you can see frameworks and tiny machine learning models make it possible to run complex AI models even on resource constrained devices like microcontrollers or smart devices, sensors and actuators, and other small computers. And next, you can see the custom deployments, which is gaining the trends here. Like companies are moving past generic tools, creating a tailored edge AI solutions and leveraging AI ops for remote system management. And next, you can see the security and privacy, which the growth of zero trust security, AI-driven threat detection, secure on-device processing, and encryption keeps the data safe at the edge. And lastly comes the 5G and IoT integrations, where the 5G networks provide the fast, reliable connections, where edge AI needs for applications like AR, VR, industrial IoT, and autonomous vehicles. And when you see the right hand side, like the convergence of these sensors, microcontrollers, edge AI providing the smart edge intelligence. So this convergence is really a game changer for the industries. Like sensor have evolved from just collecting the raw data to pre-processing it. And in the case of microcontrollers, which is traditionally handled by a simple control task, now it is embedded with AI ML cores to run inference locally. And combined that, they make it possible for devices to sense, process, and act in real time, all at the edge. And we say this in smart cameras that detect events without streaming gigabytes to the cloud, or robots that adjust the changing environments instantly, and industrial missions that predict failures before they happen. And truly, like overall, you can see the edge AI has a real sustainability impact by reducing the need to send a massive amount of data back and forth to the cloud. And companies can lower their energy consumption, also shrink their carbon footprint, which is an important step towards the greener operation now. And so, from faster insights to a better privacy and smarter industries, and also lowering the emissions, edge AI is truly reshaping how we process the data at the edge.
Thank you, Baron. Jabez, would you like to just to sort of summarize the points here regarding the sort of key drivers powering the shift, as well as the sort of the roadblocks that are getting in the way?
Sure. Thanks, Gary. At Frost Sullivan, we look at the edge AI shift not just as a technological leap, but as a systems level transformation. So to scale it, we need to look at both what drives it forward and what holds it back. So let's start with the drivers, the enablers. So first and foremost is the real-time decision making, whether it's obstacle detection in autonomous vehicles or anomaly detection in a factory line. Edge AI enables instantaneous responses without round trips to the cloud. So secondly, we have privacy and security. This is especially critical in regulated industries like healthcare and automotive. Processing data on device helps companies maintain compliance while reducing exposure to breaches. Third, we have the total cost of ownership. So by minimizing cloud dependency, both in terms of bandwidth and inference costs, organizations are finding edge deployments more cost efficient over time, especially at scale. And finally, energy efficiency. So always on battery powered applications are now possible. We've seen this with Sentience voice interfaces in earbuds and wearables running at a sub milliwatt levels. So, but let's look at the other side of the equation as well, the roadblocks. So one big challenge is the compute memory power trade-off. As you see, so fitting meaningful AI into devices with say kilobytes of RAM and milliwatt level power budgets is incredibly tough, especially without sacrificing accuracy or responsiveness. Second is the tool chain fragmentation. So teams often struggle to move from model development to efficient edge deployment due to inconsistent tool sets. Third, we have the OEM integration complexity, where embedding AI into legacy systems often involves tight hardware limits, long validation cycles, and even coordination across fragmented software stacks. And finally, model efficiency limitations. As you know, many models simply aren't optimized to run efficiently on constrained edge devices, leading to either performance degradation or infeasibility altogether. So the takeaway here is, while the drivers for edge AI are indeed compelling, the challenges are equally real. So bridging this gap with the right architectures and design strategies is where the next phase of opportunity lies.
Thanks, Javed. And thanks, Javed. And Kurt, would you like to sort of just give us your impression of this from the sort of the driving seat, if you like? How do you interpret these sort of drivers and restraints, and how you dealing with them?
Yeah, no, I think that it's really summed up by the Frosties here. I learned a new word. It's my favorite one. And when we look at edge AI is that you've got generally the increase in privacy. So you're only sending stuff to the web or sending stuff to the cloud that you absolutely have to. I think a good example is like a license plate detector. Since you could basically say, look, I found the license plate I want, as opposed to the way that it's done using cloud AI is you send every license plate to the cloud. So I think that's kind of a violation of privacy, I guess, depending on what country you live in. Reduction of power, battery powered devices, increase in latency. I think that's a good one. There's a lot of examples of like video doorbells, where if you put the edge AI in the doorbell or put the AI in the doorbell, you get an instant response. If you do it in the cloud, sometimes there's a multi-second round trip delay, and by the time you open your app, the person's already gone. But I think the most important is the energy efficiency, and then the correlation to that is really cost. So as correctly said, is that you can reduce the energy efficiency or reduce the energy consumption by say 80-90%. But if you reduce the energy consumption in the data center by 80-90%, that energy is effectively dollars, and you're paying for compute time. So if you can reduce the energy by 80%, you're probably reducing your cloud cost by an equivalent amount. And I think that is going to be the biggest driver. And you can have a little bit of OpEx, invest in some edge AI, a little bit of CapEx, invest in some edge AI, and then greatly reduce your ongoing OpEx. And I think that's going to be the major driver, is people are going to look at their cloud expenses and say, holy smokes, I'm spending all this money. Why can't I just push this off to the device?
Thank you. Thanks, Kurt. We've got a poll question in a moment, and we'll maybe test some of your thoughts there and get and see from the audience what they think of the sort of the most attractive sort of drivers. Harry, welcome to the call. Let's go.
Yeah.
Back one. Yeah, your perspective, please.
Yeah, maybe just one thought I'd like to add. I very much agree with the grouping and sorting of the Frosties. What I would like to add is at SEMA we actually differentiate between two different worlds. One thing is the AI-defined product. I mean, people in the car world, they talk about software-defined vehicles. We only talk about AI-defined vehicles because we think this is the much bigger shift that's happening right now and has just begun. But the AI-defined product means you add the ML capability and the product itself can do some magic. Everybody knows the autonomous car. And by the way, you can very easily understand the 4 drivers that you pointed out, like latency, the first one, speed. Nobody wants to sit in a car and like 1 minute after you crashed into the tree, you get the warning, be careful, there's a tree coming. So it's clear that those things really matter. The right side, however, I think is something very much overlooked, meaning it isn't the product itself that can do some magic, but the process. Let's say it's the production process or any kind of process. If you put the AI power into the process, you can outperform pretty much anybody doing the same thing. And that's a leapfrog moment we see in a lot of industries where even longtime leaders of the game, maybe being the ones doing the best gear shifts and whatever, if you have a better way of producing stuff, you can basically outperform anybody that was leading the game with, I don't know, 50 years of experience advantage. This is a pivotal moment, I believe, in a lot of production industries. And that's why we say the AI-defined process is a very interesting use case. And later on, maybe I get the chance to talk about some of the examples, what I mean with that.
Thank you. Yeah, thanks, Harry. So that's section 1. We're fairly well on time, just a couple of minutes over, but we can pick that up. Let's move on to section 2, how industry leaders are shaping the edge. So again, we'll just sort of kick off with Jabez giving an overview of this, and then we'll have a few sort of real-life examples from Kurt and Harry. So Jabez, over to you.
So one of the most important realities of Edge AI is that there's no universal architecture. So instead, what we are seeing is a layered spectrum from ultra lightweight inference near the sensor to high performance logic for complex edge environments. So let's walk through this architecture map. So at the foundational end, we have near sensor AI. So this brings inference as close as possible to the sensor itself, enabling always on voice, audio, or motion detection at ultra low power. So Sentient is a pioneer here, powering earbuds, smart speakers, and wearables with wake word detection and keyword spotting, all on sub milliwatt power budgets. So next we have the machine learning system on chip, MLSoC. So this is where we move into more complex workloads. So MLSoCs integrate a CPU, DSP, and NPU in a tightly optimized architecture. So Sigma.ai, as you know, is a leader here, enabling vision-based machine learning for robotics, industrial inspection, and autonomous mobility. So their software-based stack delivers high performance with lower power. So next up, we have the microcontrollers enhanced with neural co-processors. So this is a sweet spot, I may say, for many consumer-facing OEMs who want to incrementally, embed intelligence without changing the system architecture. So we see this in maybe smart refrigerators, home security panels, or even automotive ECUs. Vendors like STMicro, NXP, and Renaissance are leading in this segment. Next, we have the edge tensor processing units, or maybe the ASIC based inference. These are designed to deliver best-in-class performance per watt. Halo, for example, it's used in real-time video analytics and also in smart city infrastructure. Next up, we have the FPGA-based edge AI. So here, FPGAs are favored where flexibility and a rugged deployment matter. So AMD and Lattice solutions, allow reprogramming for different machine learning workloads, which could be seen in telecom and defense sectors. And finally, at the frontier, we have the neuromorphic chips like the Intel's Lohi or the brain chips Akida, so which mimic the brain's spiking neural networks. Still early, but promising for event-based AI and even adaptive learning. So across the spectrum, from near sensor to neuromorphic, the key is aligning architecture with a specific power, latency, and also workload demands. So with this architectural lens in place, I'll hand it over to you to expand on how leaders like Sentient and Seema are navigating.
Yeah, thanks a lot, Josh. So Kurt, over to you about how you're tackling hardware software co-design and its real world applications. That'd be great.
Yes. Pardon me. So when we started Sentient, let's see, in 2017, told our friends we were starting a chip company. They all kind of laughed at us and said, "Hey, no one started a chip company in like 20 years. What you really need to do is start a software company." It turns out we did. We just didn't know we were starting a software company at the time. We realized, pretty early on that just building silicon by itself was not really going to get any volumes. So we started off, we built an ultra low power device. Compared to an MCU, it's 100 times the efficiency, 30 times the throughput, and half the die size. So we generally can compete on power, performance, and price. But silicon by itself is kind of like a fish with a bicycle. It's interesting, but not particularly useful. So we basically started a software business. We acquired a software business. We also built one internally where we have turnkey machine learning models, and these models do things from wake words to commands to computer vision, all the way up to small language models that run on edge devices, and that has really enabled our customers to go to production. Because many, when we started, only really the hyperscalers had AI software capabilities. Now there's a lot more in the industry, but still it's relatively rare to see production machine learning models, and we're one of the key providers for that. And then just recently, last December, we bought the consumer MEMS microphone business from Knowles Corporation. So, with the combination of the sensors, the models, and the processors, we can now go from sensor to outcome. And I think this is a very powerful value prop for our customers, is that they don't have to do a lot of work, is that we can offer this turnkey from, here's the sensor, here's the processor, and here is the software. Right now with the sensors, and we're one of the world's leaders in microphones, during this call, we'll probably ship around 200,000 microphones. So it's high probability you're talking to us on one of our on a Sentient microphone right now. So with this is basically how we get our customers to production. And our view of edge AI is really it's the bridge between the real world and the digital world. So we what is the bridge to the real world and the digital world? We often call that interface. And if we look at the history of interface, for computers, we started with keyboards, and back with MS-DOS, it was about 150 million units a year. I mean, it seems kind of quaint today, but that got us going. And then we had the mouse, and the mouse enabled Windows and Macs and things like that. And that's around 500 million units a year. And then our next generation interface was touchscreens. And the touchscreen, we'll call that 1.5 billion in a good year. I believe the world is going to natural interfaces. And every time the interface becomes easier, it gets to about 3x larger. We went to a lot of work today to talk. You joined the webinar, we're all in this webinar today. But all of these interfaces require three things. They require microphones, they require processing, they require models. And this is where Sentient is focused, is making the natural interface the next generation interface for any device. So to double click a little bit more into the hardware, we're all, I think most of the people on this call are interested in the hardware, and our approach was, let's look at really what the bottlenecks of machine learning are. The bottlenecks of machine learning, unlike traditional compute, are really around memory. The performance and power bottlenecks are around, how you can move things in and out of memory. And then the second bottleneck is, how do you actually process models? Or how do you process machine learning operations? So, is it a convolution? Is it a recurrence? Is it an activation, or so on? So what we built is a special purpose processor that understands what machine learning is. Instead of having a compiler in hardware, we actually understand what a convolution is. We understand what a fully connected is. And this allows us to make the fundamental unit extremely efficient. We operate over 80% efficiency for most neural networks. So the tops that are in our devices are the tops that you get, which is really not the case in a lot of processors. And then, as I said earlier, the at-memory compute is really what addresses the fundamental bottlenecks of power and performance. So we have an extremely, very efficient system where we've tightly coupled the arithmetic units with the memory. So effectively things don't move around a whole lot in our chips. And then we've optimized for streaming models. So audio is often a streaming interface, and that gives us another 10x kind of advantage. So, to throw some real numbers here, often you can compare to MCUs and MPUs. So we're comparing to an ARM A53 today. I think most people would understand the performance of that device with an NDP 200 running an image interface. So this does not take advantage of the streaming goodness of our devices, but it does do the regular ML operations. This is largely a convolutional network. So inferences per million cycle, we're at 1.3, the ARM is at 0.047. So for every click of the clock, we do 30 times the workload. And then microjoules per inference, we're at 166, and the ARM is at 16,000. So we're doing the exact same work at 100 times lower power. So what's this mean to the real world? Our sales pitch is pretty straightforward. We say, look, if you're running it on traditional compute and your battery life's 3.5 days, swap out with a sentient device and you get a year with no compromise of performance. So that's what we're doing. We're bringing the sensor, the hardware, as well as the machine learning software to be able to enable voice and natural interfaces. This is the next generation device interface.
Thanks, Kurt. Yeah, impressive statistics. Thanks for sharing those. Over to you, Harry.
Yeah.
To expand on your full stack approach and compiler-driven edge acceleration. Over to you.
Yeah, sure. So first of all, as in your table, what we're doing is an SoC. We call it the ML SoC. The device has about 50 tops, but has beaten multiple times at 280 tops or an AGX. So we're in an interesting, different position here than what Kurt is doing, which I really like what he presented. The basic ideas are exactly the same. We often say we're a software company building our own silicon. That's our first slide. And if we go to any customer, because it's really about, you have a lot of secret sauce in your chip to be power efficient and to be fast. You don't want to have the customer learn your secret sauce. You need to provide that interface to their high level PyTorch, TensorFlow, whatever they do. So the left side, this any part, is really about how do you make life easy for a customer to use your devices. So to get the advantage of power efficiency and of high speed without being a chip designer and understanding the details of the clever ideas that were put into the chip. Our stuff reaches from CNNs to vision transformers to large language models that we run up to 7 billion parameters. So it's a really wide array that we're tackling here because everything is controlled by software. That's the basic philosophy. And the push button part on the right side, our idea is if you talk about a model, that's one thing. If you talk about an SoC, it's actually about the pipeline, the speed, the low latency. The model is one thing. The real speed comes up if you can accelerate the whole pipeline. And that depends actually on how do you get all the pre-processing, the inferencing, and the post-processing in one device. And that pipeline building, how easy or how hard is that made? And that's really our basic point here. And maybe we go to the next slide. Our proud moment was, it started in, I think that was March 23. I guess a lot of the guys here in this call know MLPerf. It's the so-called Olympic Games of machine learning. I think founded by NVIDIA a lot of years ago, and NVIDIA has won all gold medals ever there. Till in the year 23, a tiny little company called SEMA stepped up into the ring. And actually we've beaten NVIDIA by a huge margin, since then beaten them 3 times in a row, actually to a point where they don't show up for the edge competition anymore. They win everything on cloud, but they decided they have no chance on the edge because their product is not designed for the edge. And that was a proud moment for us. a lot of interesting facts in there. It's our production compiler. At that time, it was our old thing on 16 nanometers versus an Orin AGX on 7 nanometers. But I think the basic message behind that is a purpose-designed product for edge inferencing will beat any general GPU kind of technology. And that was what we have proven now 3 times in a row. Maybe you come to the next slide. I would like to a little bit elaborate on the what are we excited about. And I've been in production processes basically all of my automotive life that I spent before I joined SEMA. And a lot of those processes are open loop. You have some checks and balances, but in the end, you have a product that falls off the line, might be a car or something you built into a car, or any other product. You have a quality team checking once in a while if that product is okay. What AI enables that you actually watch every single product as if you had the best human expert watching this part with all the time in the world to make sure it's a perfect product. That's a dream come true in itself for anybody in production, making sure every product leaving your plant is perfect. The even more interesting part is the feedback part. What if the product is good but not perfect, and you understand how to turn the levers and dials in your machine so to make it even better? And that means you're not only delivering good parts, you're not even producing bad parts anymore. That's a big change that's happening. And maybe next slide, where I can explain that on a very easy example from a customer. That customer is doing gluing robots. You guys might know that cars are not welded, they're actually glued. You put glue on this, and you press it on the car, and then you put 4 points to fixate it, but the glue actually gives the stiffness in a crash. So the big task is, how do you put the right amount of glue on something like that? Because if you put too much on it, it squeezes it out and the car cannot be painted anymore. It's a scrap. If you put not enough glue on it, it's not strong enough. So it's a really tough problem. And you can imagine if you're into this, it all depends on the viscosity. There's a lot of Navier-Stokes equations in there. There's temperature dependency, humidity. What if some particles are in the nozzle? So everything in there needs to be programmed. It's a hell of a job. And if they've done the job right, then you get the right width for every element you want to glue here. Problem, of course, arises if the supplier of the glue changes just a tiny bit of the recipe, or his suppliers change the recipe, so he doesn't even know about it, then nothing works. Then they have to stop the line. The right side, that young lady does something completely different. She doesn't know anything about viscosity or Navier-Stokes. All she does is closed loop. She presses the bottle, she knows what result she wants to see, and she changes in real time the pressure on the bottle or the movement of the hand to get the right gluing result. It's a very simple process. If you think about it, everything we do as humans is of that type, closed loop. It all depends on being fast, because if that young lady reacts only 2 minutes after squeezing, it's going to be a mess. Probably that's how I would glue with a bottle like that. But what we're doing now with the customer is doing exactly that, putting a camera in front of that gluing robot and a very fast chip of ours and reacting in real time on any parameter change so you can overcompensate anything. And that's what I mean with closing the loop on any process, which feeds back to the argument that the Frosties made on low latency, because any kind of control is dependent on low latency. As soon as you have high latency, your process will get unstable and the results are not good.
Yeah, thanks, Harry. I mean, on that point regarding latency, reduced latency was the favorite answer in terms of the main drivers for the development of the sort of acceleration of the technology implementation, if you like. So that kind of chimes with what you've just mentioned. Very good. So that tree should be avoided, to use your metaphor, in the future. Very good. So where are we seeing these technologies being applied? What are the real world applications? Where is it delivering impact? So Varun, back to you. In a couple of minutes, there's a lot on here, lots of different applications. If you could spend a couple of minutes just sort of taking us through some vertical specific applications, and then we'll hear some again some comments from Harry and Kurt afterwards.
Sure. So in this section, we look at where Edge AI is already delivering and creating value, and the industry is adopting it fastest and in practical way, it's transforming the operation on the ground. So if you take the manufacturing industrial sectors, factories use Edge AI to predict failures and inspect product quality instantly and keep workers safe. So all without sending any terabytes of data to the cloud. For example, like companies like Siemens and GE are already embedding Edge AI into their industrial equipment to continuously monitor the vibration, temperature, and usage patterns. So this helps them to detect early signs of wear and tear and failure. So maintenance team can act before any unexpected breakdowns disrupt the productions. And also you can take an example of Foxconn company as an example, which has implemented AI-powered vision systems on its assembly lines. So these systems inspect products in real time, spotting any defects at high speeds without needing to send data to the cloud, and ensuring that consistent quality while there is a reduced wastage in their production plan. And the recent like Tesla's gigafactories use robots with edge inferencing capabilities. So these robots can adapt to different tasks, like detect obstacles instantly and collaborate safely with humans. Therefore, they are boosting their flexibility and workplace safety. And in the case of automotive and transportation sector, vehicles are effectively mobile edge nodes, like autonomous driving and ADAS application rely high speed local processing to interpret surroundings and make split second decisions. And smart cities and infrastructures. So cities use Edge AI to improve traffic flows, enhance public safety, and optimize utilities, often in real time and without a constant cloud reliance. And in the healthcare and medical space, like where Edge AI in healthcare means a lot for the patient's data, which stays closer to the source, which improves the response time and protecting privacy, especially in remote and critical care settings. And to say an example, like the Mayo Clinic, which is one of the top ranked hospitals in US, has partnered with NVIDIA to use Edge AI for instant analysis of medical images, including X-rays and pathology slides, right where they are captured. And this enables the radiologists to detect abnormalities immediately and prioritize the urgent cases, which also can be a life-saving in the case of strokes or cancer detection patients. And hospitals like Mount Sinai in the New York City, they are piloting AI-powered bedside monitors that analyze vital signs locally to detect signs of deterioration in real time, which enables rapid intervention when every second counts in human life. And if you take the retails and consumer device, they use the Edge AI for smart checkouts and theft detection, while consumer benefit from devices that process voice and video locally for speed and latency. And the energy and utilities, this sector uses the Edge AI to monitor grids, balance loads, and predict failures, all critical for uptime and sustainability factors. So these real world examples show the Edge AI is not a theoretical one, but it's reshaping how industry operates today.
Thank you, Varun. So quite a variety of applications. Harry, would you like to give us a minute or two of some interesting use cases from your perspective?
Yeah, sure. 3 cases I brought with me. Trumpf is the laser hero company. Same idea, real-time closed-loop welding. Their idea was to do this. Problem was 1,000 frames per second were coming in. They couldn't do more than 500 on a graphic card. We provided that with 4,000 frames per second, and now they can actually check the welding while they're doing it. Please, next slide. More straightforward, we talked about logistics. That's the biggest logistics provider in India. Going fully into this very interesting use case. And again, it's all about heating, battery life, all the topics we touched, why this matters and why they wanted to have a hardware that's better than a high power GPU based architecture. Please, next slide. Last one. Baxter is the biggest company in this space of infusion liquids and stuff like that. They had a task to find impurities in their infusion bags. That's how it started. We are now doing 10 different projects in parallel with them. And again, for us, a big point was we solved a problem that wasn't solvable before. It's a 64 megapixel camera looking at those bags, high speed of the bags flying in. It just tells you the same story that Varun and Jabez talked about, high-speed inferencing as a real use case in those production sites. That's it.
Yeah, thanks. And we know that sector quite well, the hospital bags and infusion bags. So it's a big market, and a lot of attention paid to it. So glad to see you're making moves in there, Harry. Kurt, from your perspective.
Yeah, no, first of all, thank you, Harry. I think those are amazing applications. I'm actually super excited about that welding one. So what we're doing is largely battery powered. I like to describe it as earbuds to automobiles. These are generally areas where we have made the interface a smart interface. Earbuds and hearing aids are kind of obvious. They're small with little batteries. Automobiles, maybe not so obvious but what we're doing there is security systems. I have a recent blog on LinkedIn about this where, instead of having an electric car with a huge battery, you could do in an ICE car or internal combustion engine car, you could have the same kind of functionality that you would see in a Sentry mode in a Tesla or the security system in a Rivian or something like that. You can take something that you would normally only see in a big battery powered car and put it into an ICE car. So run a couple of weeks in an airport parking lot with full security on a 12-volt battery. So our range is remote security cameras, doorbells, and so on, all the way up now to set-top boxes where we're doing large language models inside devices. So effectively putting a conversational interface inside of a device that works without any kind of internet connection. And then we've got a little over 100 million units deployed. And then lastly is an area that we really haven't talked about so much is U.S. government Sentient is one of the I guess top VC based U.S. government providers. And the whole idea here is let's put edge AI into the warfighters' hands so they don't have to go to the cloud. And the assumption here is any kind of intelligence that needs to be done in a conflict needs to be done in real time without a cloud connection. And this is what we're doing for our U.S. government business.
Very good. And yes, a growing industry, I would suggest. Yes, thank you very much. And thanks to the audience, to those people tuning in for the last poll. So we've got one more for you. A penultimate one, actually. There is one last quick one. If you'd like to just sort of give this some thought in terms of, like you just heard, where do we think this technology is going to receive its strongest level of deployment? Then please make a choice. We could have put in there all of the above, but that's not much fun. So make a choice and go out on a limb and choose one of those that you think will be most significantly impact or benefit from the technology. And we'll come back to the responses later. Thank you. Okay, I think we're on to our final segment now. So pretty good for time. I think we're a minute over, but that's good. Thanks for making up a bit of time in that last section. So looking ahead, what's next? Harry.
Yeah.
You like a bit of imagery? Give us your
exactly. I'm doing this. I'm doing a quiz show like you did. I guess most of the people don't know the people. I didn't know. I looked them up. The pictures. If you go to the next slide, they have one thing in common. They all talked about the ghost in the machine at different ages. Their vision was, what if a machine is more than a machine? And we've seen all science fiction movies on that. And if you click one time, we actually believe we're putting the missing element into the equation, a chip that is able to do this ghost in the machine job with an acceptable power envelope. Because we all know it's possible in the cloud. We all know the ChatGPT moment that we all had and whatever Gemini and whatever is out there. But how do you put this in the cloud? And we believe that is a pivotal moment in terms of how you operate machines. If you go to the next slide, in fact, this concept, maybe click one more time. if you think about it, how many devices and how many units are surrounding us where you need an instruction manual, or if it's like a production machine where you actually need a training to operate this. And we believe this will fundamentally change. Please, next slide. You can do this all on the edge, and one of our biggest customers right now, and that is a huge contract. It's all about the UX of a car. How do you operate a car? We all know the voice commands that you give, more or less well done, sometimes with a low latency, but you always feel it's a machine and you're waiting for a machine. What if that would change and the car feels like a human being? Some of the people might be old enough to know a TV series called Knight Rider with a car that's called KIT. It was just a direct communication partner. And I see big excitement in the automotive world that will change the way we operate cars forever. And any car not having that will look really old compared to a car that has this ghost in the machine type of feature. And you could extend that to multiple other objects. And we believe this is a very interesting application of generative AI on edge devices. And we're talking about billions of parameters of models that are very capable, speak all languages, and understand you no matter what accent you speak. Please, next slide. I think that's my case, right? I hand over to the Frosties.
Yeah, back just back one there. So I think Kurt, anything you'd like to add in terms of where you see, this is a Frost slide, so we'll cover this in a minute, but where you see the sort of future headed?
Yeah, I think that, my view is that AI is the next generation interface, and we're working from our sensors to our processors to our software, and I agree with Harry completely. I can't actually wait till I can have a full conversational interface to my car. I think it'll be it'll be an interesting thing. Is that is that car going to be my car, or is that car going to be a shared car as well, right? Is there's
Yes,
what is that future turn? And I just saw a note, somebody said on Yahoo News yesterday that the next generation is not going to learn is not going to be able to drive, which is terrifying to me. I love the drive, but I think it's a wonderful world that we're going to see in front of us. And
yeah,
and
I mean, in a number of sort of developed or mature economies, Kurt, I mean, the number of driving license applications is falling, right? So there are fewer and fewer being given out.
It totally is, and I I have 3 kids, and one drives all the time, and one doesn't drive that much at all, and one's sort of in the middle, and I just think it's better to have the freedom to be able to jump in your car and go drive, and then pretty soon with the Gen AI in the cars, we'll just be able to talk to them, which will be great.
We will see.
I think that the real key though, that we're all working towards is for this to work, it needs to be transparent. We sort of trained ourselves to say a wake word plus some commands to work with our echoes and whatnot. I can press a button on my Tesla and give it voice commands. I can use a wake word on the Rivian and give it voice commands. But the real point, I think, is the next generation of edge AI, or maybe it's 2 generations away, is this is transparent. You don't even know that it's there. And you don't say, well, this is a smart glasses. It's just, these are glasses. Or this is a smart car. This is just a car. I think that's really where we have to be, is that you don't know that there's edge AI. You don't know that there's AI at all. This is just how it works.
Yeah, so it's an inherent property of the product, and it's just an assumed capability, right? So
it's just there.
Yeah. Yeah, and we do know, we do a lot of work in this sector. We do know that the decision-making process behind buying a vehicle or any product is changing, right? In terms of what people are looking for and what people are specifying. Once upon a time, it was number of cylinders. These days, it's CarPlay or safety features. So it definitely is evolving in that respect. Thank you.
Yeah, my house, it's still number of cylinders, but
yeah, if you moved to the Bay Area or to San Francisco or to London or something, you might get a different response. Very good. All right, just sort of closing up really. Which of my colleagues will take this on? Just a sort of Frost view of the sort of future sort of roadmap for Edge AI. Jabez, is that on your list? Just to
Yes, Gary. Yeah, I'll
close
take
off.
this up. Yeah. So, firstly, thanks to Harry and Kurt for the excellent viewpoints on the future of Edge AI. But again, coming to the research of Frost and Sullivan, we are increasingly seeing, and I would definitely be echoing your viewpoints, seeing the future of Edge AI not just as a way to offload cloud compute, but as a shift towards embedding intelligence into the smallest, most context-aware parts of a device. So it's about moving intelligence closer to the real world, where decisions need to be made instantly, locally, and efficiently. So, and this evolution isn't happening all at once. It's unfolding in clear, phased transitions. So, in the near term, we expect to see machine learning SoCs scaling in industrial AI, supporting tasks like vision inspection and robotics control. At the same time, we'll see AI integrated MCUs become a standard in smart homes and consumer devices. And of course, near sensor AI, especially for voice and gesture, will go from niche to, I would say, mainstream across wearables and IoT. So in the next second phase, architectures will evolve further. So sensor fusion chips will start combining vision, audio, and motion into unified models. So OEMs can be seen to co-develop vertical AI stacks, particularly in sectors like automotive, robotics, and even smart infrastructure. And in fact, we will begin to see edge devices that can learn locally and not just infer. And just echoing what was discussed earlier, enabling real-time personalization without relying on the cloud. And moving on to the longer horizon, we do envision energy autonomous AI systems drawing ambient energy to operate 24/7. So we'll likely see neuromorphic MCU hybrids, which could lead to ultra efficient contextual learning at the edge. And ultimately, fully autonomous edge agents, whether in hospitals, retail, or factories, managing tasks without human intervention or centralized control is where this could be headed. So as we look ahead, edge intelligence is moving beyond narrow tasks and towards full autonomy, embedded directly into the fabric of everyday devices and environments. So with that future-facing vision in place, I hand it over to Gary. Talk us through.
Thank you. Thanks, Jarvis. And just kind of finally, just wrap up. At Frost, we always like to identify where we see growth opportunities, and we picked 4 here, which should be sort of fairly self-explanatory. So number 1 is the fact that the integration of these concepts is critical. This is what the whole session today has been about. So sensor AI, sort of MCU synergy is critical. Verticalization will drive scale. What we mean by that is sort of domain or application specific solutions. So we heard about vision for robots on the sort of the gluing of the car chassis or the car sort of body panels, for example. Audio for wearables, edge inference for industrial automation, etc. So sort of domain specific customization. Number 3, sort of software first approach wins. We heard, I think, from both of our guests today really about how sort of the software first business is how they sort of viewed the evolution of their firms, and that's what we agree with. And finally, and this is something that we see in many industries which are driven by sort of technology and technology convergence, I suppose, is that ecosystem collaboration is essential. No single company will own the edge, and to compete and to win, you need to drive partnerships with various different sort of value chain players, sort of OEMs, sort of co-development, etc. So this is essential here, but it's kind of becoming increasingly important in all of the sectors that we work, where there's sort of various megatrends at play, sort of global convergence driven by sort of technology. So so three areas where that we think are sort of great sort of opportunities for value chain players. So this is kind of it, really. I mean, this is the sort of the end of today's session. We've heard how Edge AI is reshaping not just how machines function, but how intelligence itself is embedded directly at the edge. We're moving into a future where real-time decisions, ultra-low power performance, and domain-specific AI models will define competitive advantage. Whether it's in factories, vehicles, retail spaces, hospitals, the combination of sensors, MCUs, and scalable AI is unlocking new growth opportunities that were previously unimaginable. And it's been a pleasure having the panel with us today. I mean, at Frost & Sullivan, this is what we do. We help companies navigate this transformation as these markets evolve and throw up opportunities and challenges. We help companies to drive that, and we have a growth pipeline dialogue approach that we take, which I think is on the final slide. If we can just move to that, Varun, just a few contact details from Frost & Sullivan. And I'd like just to finish on time, which is great, just by thanking the panel, Varun Jabez from Frost, and obviously Kurt and Harry. Great to meet you through this process, and we look forward to sort of sharing this information with many others through sort of online channels afterwards. And thanks to all of those who joined in right now via Zoom, via LinkedIn, or in the future via our on-demand service for this. So I hope you've enjoyed what you've seen.